Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your technical questions answered, and contribute to the community forum. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our construction, tech, or weekly Global Passive House Showcase webinars. In the meantime, here's this week's Passive House podcast. Well, welcome back to another episode of the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from Auckland, New Zealand.
And I'm Zach Semke, coming to you from Seattle, Washington.
How are you doing, Zach?
I'm well. I just had my booster a couple of days ago and was laid low for about 12 hours the next day, but I'm back at it. And our
Nice.
two boys got their second doses as well. So we're ready, knock on wood, for Omicron. How about you? How are you doing?
Yeah, pretty good. We're coming up towards the end of our year on the Southern Hemisphere. Schools kind of what is left of school for this year is almost about wrapped up, and I think everyone's keen to. We're going to be let out of Auckland soon, which has been interesting. They're going to let us out and go and travel, at least domestically. So a lot of people will be on the road over Christmas, I think, and
nice
over the holidays, going visiting other places around. And so hopefully it'll be all good.
Good.
Yeah. But some good stuff happening. We're going to carry on the show. Is that the plan?
Yes, the podcast is going to extend through our winter break and your summer break. Yeah. We got some great interviews, and I know a lot of shows shut down, but I also know that I quite like having good things to listen to over the break. So hopefully we'll have some good content to keep people interested if they want a bit of distraction. So let's get into it, because we've got a bit of a long interview and a great interview this week. But let's thank our sponsors first. Yes. So thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minitaire All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwell North America, Stillcorp, and Zola Windows. Thanks to our champion sponsors, Icon Windows and Doors and SIGA. And thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority.
Awesome. All right. Now, before we get into this week's interview, a little bit of jargon and conversion. The number 475 crops up, which we have talked about before. It happens to be the name of one of our sponsors, and for good reason.
Yes.
475. Is not as relevant to us here in Metric World as it is to you, but it does have its roots in the energy usage, energy demand of Passive House. Is that correct? I'm probably butchering that.
That's right. Heat demand, the heat demand target for PHI certified projects. So it's 4.75 kilobtu's per square foot per year is the heating demand limit for Passive House.
Such an easy to use metric and easy to work with numbers.
Yeah, Imperial is so wonderful. Yeah, definitely.
So that would be 15 kilowatt hours per square meter for us. Now, the other bit of jargon that came up was heating degree days, which is a really useful term because it localizes how much heating you need for any particular place on the Earth, because you look at the different. It's basically a cumulative
number of the difference between optimal temperature that you want inside and what the fluctuation of temperature is outside. So the more extreme climates, the cold climates, have a larger number of hours per year when there's a difference between the outside temperature and the inside temperature. And heating degree days looks at the number of those hours, but also the size of that difference, and adds it all up and gives you a number. So I assume when we're talking about thousands of heating degree days, we're talking about Fahrenheit degrees.
Yes. Yeah, good point.
Which will be slightly less than Celsius degree days, but not a huge difference. But suffice to say that we're talking about some pretty cold climates.
Yeah. This is mountainous. This is the Rocky Mountains.
Yeah.
So very cold
all
winters.
Right. I think that's all that I picked up on. Let's get stuck into it. You want to tell us about Skylar?
Yeah, well, Skylar has been a Passive House kind of thought leader since the early days of Passive House in North America, despite his relative youth. And he introduced me to Passive House along with Sam Hagerman when all of us worked together at Hammer and Hand, and was a close collaborator with me in our communications work there about building science and Passive House. And so you'll hear about that in the interview. He runs his own consulting company where he does Passive House consulting, and also is running his family business, which is focused on insulation and kind of building science interventions in the Rocky Mountains.
All right, let's get into it. Here is your chat with Skylar.
Well, I have Skylar Swinford here to talk with us on the Passive House podcast. Skylar is a dear friend of mine and introduced me to Passive House along with Sam Hagerman. I think we're going to get into this a little bit. Sam Hagerman of Hammer and Hand back in the day. And when I first met Skylar, and talked about his work and his kind of building science knowledge, I would refer to him as a wonderkind of building science, or for Ted Lasso listeners, I guess we could say wonder kid. But Skylar is now too old to call a wonderkind. So
very true, Zach. Very true.
But Skylar, it's so great to have you here. I'm really looking forward to talk to you.
Thanks for having me, Zach. I'm definitely too old to be a wonder kid. And having not seen season 2 of Ted Lasso yet, no spoilers, okay?
Yeah, fair enough. So Skylar, I think you have a really unique background and pathway to Passive House. Can you share that a little bit?
Yeah, kind of the broad picture view is my dad was a builder growing up, and then he transitioned to doing high performance insulation and air sealing, because as a builder, he had a hard time finding someone that would do the insulation and air sealing details right. And he started to do it himself. And he established that there was a market for that. And we were located in the mountains of central Idaho, which is a very extreme and cold climate versus a lot of the climate you might be familiar with in the Pacific Northwest. There's about 10,000 heating degree days, and it's on the edge of climate zone 7, and has more heating degree days than like cities like Helsinki, Moscow, Stockholm. So it's quite a cold place, and can get up to 250 inches of snow fall a year. And so there was a really high importance on the building enclosure and the thermal envelope, because of the cold climate, and which, as we know, is one of the principles of Passive House as well. So I kind of had an early understanding of, as a small kid, my dad doing blower door tests and running around with like little fog puffers to see where air was leaking out. To be honest with you, I had no idea what was going on or why it was happening, but it kind of introduced me to that at a young age. And I will be honest, I had no interest in kind of getting into the construction or insulation world or anything related to building when I went off to college at Willamette University in Salem, Oregon. It turned out a lot of that early training was well suited to a career in building enclosure consulting and passive house consulting, a lot of crossover between the physics of the atmosphere and weather and climate and buildings. So that's kind of my jumping off point to passive house kind of started after my training as an environmental scientist. And I went back to work for the family biz for a little bit after I graduated. And kind of the first logical step to learn more about buildings and energy was to take the ResNet training. Mm-hmm. And at that time, when I did that training, it was in Butte, Montana. And on my way through Butte, I stopped in Missoula and met Russ Hellam, who you and I both know. And he handed me a little thin booklet. And it's that first book that Kat did. I don't know if you recall the name of it, about Passive House.
No.
I think it's like Homes for a Changing Climate or something along those lines. And he told me about Passive House, and I was like, wow, this sounds pretty crazy, 2-foot thick walls and windows from Europe. And I was kind of like dismissive and took my ResNet training and wasn't super excited about everything I learned. Definitely a great place to learn about the fundamentals of building science and how buildings work. But it's really a program at the time, at least, was designed more just about kind of code plus buildings and didn't learn a ton about building physics and energy modeling and optimization. But it was a great framework. But I took that book, started reading about it, and became super kind of enthralled by Passive House and kind of obsessed with it. And it was funny. I remember at the time creating a Google news feed search for anything related to Passive House. So that was, the German spelling, the Dutch spelling, the US spelling. I had all these news feed alerts. And at the time, I'd get really excited when there was a new article about Passive House or about a Passive House product or a new ventilation unit. And it's quite funny now looking back at that, because if I tried to keep up with all the Passive House search results these days, I can't even keep up with the Passive House Accelerator newsfeed. So there's just so much more info, which I think is a testament to how much growth there's been in the Passive House world. But anyway, that book led me to start researching Passive House, and I started emailing this guy, Mike Krenegas, at the Passive House Institute US, who at the time was still doing the trainings with PHI and FIAS. They were collaborating at this point, I think in like maybe late 2009 or so. And I started bugging Mike and trying to get in the next class, and I kept like harassing him. And then he's like, we need a resume from you. And I was like, oh no, they're not going to let me in the class because they require a resume. And I remember being super nervous about putting a resume together, which was nothing. It was like, I graduated, I took the HERS training.
Right.
And there wasn't a lot there at that point. And so I applied, and he announced that there was a Passive House training coming up in the spring of 2010 in Seattle. Kat was the primary instructor, and I remember just diving into the PHPP energy modeling software, not having a clue what was going on. And it was a lot of fun to kind of just dive into it and read the Passive House, kind of the PHPP manual, like kind of a Bible, and just trying to like understand what was going on and what a psi value was. And so it was pretty fun to go through that training and kind of grow with all these people.
Yeah, definitely. Right. And you mentioned that your resume was fairly brief at that time. Since then, it's become a fairly lengthy resume. You're Passive House consultant with your own firm, Energy Systems Consultants, based in Boise. You've served on the FIAS Technical Committee since 2016, which is a testament to the kind of collective community's recognition of your thought leadership in building science and building physics. And you've gone on to consult on lots of really notable projects throughout North America. And some of the first in the Pacific Northwest when we were working together at Hammer in Hand. What was kind of notable about some of those first projects that we were doing or that you were doing? I was watching and learning from in the Northwest, and maybe kind of how you've seen things practice evolve since then.
Yeah, I got the sense and that in the early 2010 era, I mean, there wasn't a lot of Passive House projects happening in North America, and like the idea of being in a Passive House was just like exciting. The idea of building one was just like kind of really exciting for a lot of people that were just starting to learn about Passive House. And I want to say that in a lot of ways, I was in the right place at the right time, because when we, and that was why Sam brought me in to work at Hammer in Hand. I remember him when we were doing the PHPP. He's like, "Hey, I got to run a business. There's no way I'm going to be running this energy model. I need you to come work for me." And it just so happened my wife was going to be attending law school in Portland, so that fall. So it worked out really well, and that job offer also played into why she selected going to Lewis and Clark. And so ended up being awesome timing. And within a couple months of working at Hammer in Hand, we were breaking ground on the Corunna Passive House project in collaboration with Holst Architecture, and working with Dylan Lamar, was one of the original PHPP users in the US, and he helped actually convert the PHPP from SI into inch pounds for all of us North Americans. And so just like a huge mentoring opportunity to work with someone like Dylan and to work with Corey at Holst, and awesome craftsmen like Scott Gunter, who actually was building the Corunna project. So just to kind of dive in and have, take the Passive House training, and then months later be working on one of the early first big Passive House projects was just like really lucky, I would say. Yeah. And yeah. I think you and I kind of felt a sense of needing to get this knowledge out that we were learning in real time to everyone. And that's where I think you and I hit it off, and we kind of had the idea to do as many blog posts and videos as we possibly could to try to disseminate all the building science information that we were learning and in real time, and the mistakes we were making in real time.
Well, and to be clear, that was your idea. It was like, hey, we've got this, like we're laying a kajillion square yards of geofoam at the Corunna project. You got to come down. We need to get video of this. And so I think that I mean, really your time and our time together at Hammer in Hand, we had this luxury of being able to spend a lot of hours documenting these projects. But I think that comes, it all traces back to those initial days of the Corunna House project, and you're like, yeah, we got to capture this. But that then grew into pretty significant documentation of lots of different projects via video, especially that Hammer in Hand was doing, and then also the best practices manual that you helped spearhead. And I talked to like practitioners in Seattle, architects who aren't involved in Passive House now, who know Hammer in Hand because they use that manual as a resource to this day.
Yeah, and a lot of that stemmed from there's awesome building science information out there, and tons of information about Passive House, tons of information about building science in general. for example, from the Building Science Corporation.
Yeah.
And it's kind of hard to just send the carpenter in the field like, hey, you should read this Building Science Digest from Joe Stiebrook or John Straub or or look at this book. And so, yeah, I mean, we were just trying to like simplify things, and you have to remember too, you know, one of the big elements in the quality assurance program, or what became known as the best practice manual, is the use of the fluid applied flashings. And you know, we were building in the Pacific Northwest in Seattle, Portland area, and we were lucky enough to be in the backyard of Tom Schneider and Ron Tatley at Building Envelope Innovations, where they were developing the what are now the Prosco fluid applied flashing products. And because that was one of the huge challenges, especially with Passive House, was how to flash these rough openings with these windows inset into a thick wall. And few solutions were more appealing than the fluid applied approach, and also in our wet building environment to have a product that was moisture cured and vapor permeable, because we'd all seen the projects where we used lots of vapor permeable peel and stick over the years, and then you pull the house apart and a small leak is never able to dry, or the initial construction moisture isn't able to dry behind that vapor impermeable flashing. And so to kind of like be there when these materials were being brought onto market, like I don't know if you recall that project that Hammer and Hand built kind of actually right before I started working there, was on the Columbia River Gorge. There's the airport house, that beautiful project designed by Scott Edwards Architecture.
Yeah.
And I think that was the first project, because it was high exposure. Hammer and Hand used the fluid applied flashings, and that was, you know, BEI barely had even a logo on the sausage tubes then, that we were using to squirt out into the rough openings and trowel out and use these fluid applied flashings. And so this was a long digression, but I guess my point was I wanted to get out that information of the fluid applied flashing systems. And so a lot of that was prominent in that best practice manual. And, you know, I remember when Sam had Tom Schneider and Pat Downey come to the Hammer and Hand office, and he called all the, 80 carpenters out of the field and had everyone come into the office, and he, took a stand right there and said that we were only going to use these fluid applied flashings in the rough openings. And which then obviously moved to, on the Corona house, we used the fluid applied on the entire building enclosure, which was pretty rare for a single family residential project at that time. And now it's become, pretty ubiquitous. And, that it's awesome to drive around Boise these days and see fluid applied air barriers on pretty much every multifamily building, when it wasn't like that, even 5 years ago or 10 years ago.
Right.
And so it was cool to be kind of part of some of the building science history, if you will, that was kind of occurring.
Definitely. And the BEI work is basically the products you're talking about are the Proseco, the Cat 5 and the other, the kind of that family of
Cat 5, Aerodam, Joint and Seam,
right.
Fast Flash. Fast Flash is really the main one, the red product.
Yeah.
And so, we were, Hammer and Hand was definitely on the leading edge of the spear with that stuff.
Yeah. And
those exciting to be a part of.
Definitely. And those became a big piece of the story of the Bullitt Center, the Living Building Challenge office building in Seattle, as well as kind of a success story about the Red List with the Living Future Institute, because I know that BEI did a bunch of work to remove phthalates from the chemistry of those products. So yeah, definitely. some geeky building science product, Pacific Northwest history.
Yeah, exactly.
To reminisce about.
If you're ever in Portland and you want to go, I recommend going to trying to book an appointment with Tom Schneider at the testing facility that they have. And they run different window and door install systems through the ringer there. I remember we actually had one of the Passive House windows for one of our early Passive House projects. I think it was a Zola window. we had those guys run it through their test chamber and put it through the paces. And it's just cool to have that opportunity to be able to do that. Now it's becoming more common, obviously, in commercial projects to test buildings in situ and to do the air and water testing. But at the time, it was fun to be able to throw a passive house window in the test chamber. It probably hadn't been a lot of those tested in the US at that point.
Yeah, no kidding. Well, we have so much to talk about, Skylar. So I really want to be able to hear about your house. You just finished your own passive house project in Boise. And then also I'd love to, you've been, I know, doing a lot of thinking and reading about the clean energy transition and, Saul Griffith's Electrify Everything work, and thinking about how efficiency plays into that. And I think that probably those two stories are interwoven a little bit, the story about your own house a little bit and thinking about decisions there, and this other piece about the kind of a broader societal move, hopefully, to clean energy.
I had the opportunity during summer of last year to buy a small lot in Boise, right on the edge of downtown, and just so happens my neighbor, one house over, is Scott Weiber of VY Architecture. And he happens to be a very talented passive house consultant, someone that I collaborate with on projects all over North America in terms of consulting. And he's his architecture is in the Idaho area. They also have an office in Salt Lake City. And Scott and I worked together to design my single family passive house with some considerable site constraints, where our lot is only 30 feet wide and we have 5-foot setbacks. It's a very narrow, long lot. And in terms of designing for optimal solar gain, that wasn't on the table. It's in a historical neighborhood, so we had historical guidelines to design against. And more importantly, when your house can only be 20 feet wide, you have limitations also to wall thickness and usable area. And so window placement really was done for what was necessary to meet historical guidelines, and also just like what was functional for the space, most importantly. And so every nook and cranny, Scott designed optimal kind of use out of every space with lots of built-ins, as you need to do with a very narrow house. But it also provided some constraints and challenges for getting passive house certification by not being able to harvest any additional solar gains to kind of artificially decrease heat demand. There were some challenges on that front. And then Boise is one of those mixed climates where we have fairly harsh winters, not as bad as McCall, where I grew up, that have about 150% more heating demand in McCall than in Boise, but it's still quite a cold climate. And then there's also pretty brutal summers as well. And so you really have to balance your heating and cooling loads. And it's not that the cooling demand is so great, because we do have a lot of nighttime cooling effects, which again is limited in an urban environment as well, and also with wildfires. And so kind of had the opportunity to design kind of the passive house with all the elements I've been preaching about, and more importantly, learning from all the mistakes I've learned from over the last decade of doing passive house projects. And going back to example of that Corona house, where we were putting 12 inches of foam underneath basement footings, which, now we know was probably not the best way to go about it, but we were working within the constraints at the time and not being able to do thermal bridge calculations to optimize things more. But for example, on my house, there's no foam under the footings, and we actually didn't put foam on the outside of the foundation wall, and we just eliminated all the need to protect that foam, have it exposed to moisture, have it exposed to potentially insects or whatever on the out, and then protect it where it comes above grade. And just some of the things that we've learned over the years of kind of doing lots of passive house projects, is trying to simplify and make things as buildable as possible. And also rather than it being 12 inches of foam under the slab, it's, maybe 4 to 6 inches. I think it was 4 inches ultimately is what we had under the slab. And just doing more optimization. And a lot of that was helped by this project was not a PHI project. It is pre-certified to the FIAS Plus 2018 standard, which I'm sure your listeners know has climate-specific targets to hit from the heating and cooling side. And so it kind of results, in my opinion, kind of more cost-effective building enclosure. And so in our case, we have, pretty moderate effective R values in the wall of like R38, pretty run-of-the-mill passive house, triple glazed windows. We didn't need to do anything heroic with quadruple windows or embedded frames with over insulation that complicated details. My roof assembly is just barely above code. If I were to have tried to attempt to get PHI, I would have had a very, very, very challenging time hitting the 4.75 heat demand target or hitting the peak load requirement as well. If I was trying to go around that, I would have just needed much thicker walls. And with our design, I want to say that the design temperature in Boise is like -2 or so. It's like 2 degrees. I mean, in order to hit that peak load target, it would have just been very challenging. Oh, I was incorrect. The design temperature is the 99% design temperature is 15.9 for Boise. So it's not that extreme.
Mm-hmm.
I had McCall in my head.
Mm-hmm.
But the reality is just it's a more extreme cold climate than you'd see in Central Europe, and the application of PHI to the project would have been detrimental to the project in terms of trying to add more south-facing windows to absorb more solar gains and offset some of the heat losses. And there was just no opportunity for that on this project, for example. And if we made the walls any thicker, the house probably wouldn't even been viable. And even with the passive house targets, from FIAS, we were barely able to squeak by with certification. And that's with me knowing every trick in the book in terms of thermal bridge calcs and, tuning every knob in the model to make it beneficial. And it was still a very, very narrow pathway and challenging.
Right. You were faced with a site with some pretty intense constraints. Urban infill lot, So, I mean, it doesn't get much tougher than that for passive house in a cold climate as well. Yeah, absolutely. At the accelerator, where our feeling is that both certifications are really important and valid and are key pieces of the decarbonization puzzle, and they're different. And so sometimes one certification works more for a site than others, and also they have different strengths. And
I don't want to say like a site constricted, and constrained single family project for a lot of skin and a lot of surface area is, a good measuring stick for either of them. I mean, it's the kind of worst case scenario.
Right.
And some of these issues change with different scale of buildings as well. The heat demand targets, for example, on a PHI project are much easier to meet with a multifamily project with more internal gains and less heat loss than a single family house per floor area. And so, not everything I said applies to everything, for sure.
Yeah.
But I do think FIAS has found a good kind of target for single family projects that kind of maximize the load reductions at a cost optimal perspective, because that's literally what the purpose of it was. So like you said, they have different goals, and made it quite easy to, the money I spent on the building enclosure, for example, versus if I had gone to PHI standard, for example, I was able to put that into my sand-in hot water heat pump. So I was able to get the most efficient domestic hot water system available, which, as we know, once you've reduced the building enclosure loads and the plug loads and the appliance loads and the lighting loads down to as low as they can go, the hot water is a big piece of the puzzle. And so to have that extra capital on hand to put, rather than into more sub-slab insulation, to the sand and heat pump, in my opinion, that was a favorable outcome, and kind of ties into what we wanted to talk about in terms of electrification. And so the house, we can kind of talk about the heating and cooling for this house is provided by it's about depending on what metric you use, it's between a 22 and 2,400 square foot house. It has a basement with a main level and then a story and a half. So it's technically like a 2.5 or 3-story building. And it's completely heated and cooled with a 1-ton Mitsubishi heat pump. John Semmelhack at Think Little did the mechanical design. And we worked very closely with Scott at VY Architecture to design all the distribution system because of it being such a tight house. And we were up against height restrictions, so every quarter inch mattered. So we have the smallest floor joists and tightest, everything is really compact. So it makes it very hard to run a distribution system. And without the load reduction of Passive House, I don't even know how we possibly could have done a duct distribution and also make room for ventilation duct work as well. And so, the lower loads, which on this project, on a house this size, you could easily have a 3 to maybe even a 4-ton heat pump for this house if it had been built to code levels. And so to be able to achieve it with a 1-ton, just simple low load variable capacity Mitsubishi ducted heat pump is pretty remarkable. And so we have the cold climate air-to-air heat pump in the basement, and it's ducted to all 3 levels. So the basement, main level, and upper level. And then we have a variable air volume zone control system from AirZone that allows each zone so basically each level has its own thermostat and really helps with any potential temperature stratification issues, which is something that I've battled on many past Passive House projects, which is the kind of the temperature stratification, which occurs even if you have the most amazing building envelope. It's just the natural stratification of the indoor air. And so with this AirZone system, we're able to keep our temperature on each level pretty tight, which has been great living in it. Yeah. In our case, our bedroom's upstairs and we can keep our bedroom cooler and in the wintertime, and the main level more toasty and the basement cooler. Whereas before, in order to keep the main level warm enough, you'd often end up overheating another spot in the house. And so I've really enjoyed the ability to zone, which is kind of just the ability to zone these variable capacity inverter heat pumps is fairly new technology. So it's been a great to have the tool chest for these low load Passive House projects, because you can do one piece of equipment on multiple loads or with multiple floors, rather than having multiple outdoor heat pumps or those multi-head units, which are more prone to short cycling and having other issues. So I feel like the unit definitely, based on my monitoring, and I've had John Semmelhack taking a look at the load profiles, we're seeing the heat pump unit run times are long and consistent, and which is what we want without any short cycling. And so that kind of ties back into, so far we're at December 7th. It's been a fairly mild winter, but I still find it pretty remarkable that this, 2,000 plus square foot house our heating loads are pretty much met with our heat pump running at 1,000 watts continuous. When it does run, it just kind of runs for a couple, 1 hour to 3 hour cycle at about 1,000 watts. And, compared to, a normal building, which maybe would be at 5,000 watts or more, or natural gas furnace blasting, it becomes quite evident how that low load building can be compatible with a renewable grid. And also, as we electrify our building loads, the winter loads become more concerning as well, because right now a lot of those the thermal loads are being provided by natural gas, and as we electrify those loads with heat pumps, for example, that's going to change the balance of a lot of grids in North America and the Northwest, and there's going to be a bigger winter peak, and so I'd rather bring a bunch of efficient little heat pumps in passive houses online rather than big spiky loads that we have to overbuild our renewable energy sources for, like, majorly, in order to kind of fill those winter gaps.
Yeah, you forwarded me an article from that was summarizing the work at the Lawrence Berkeley National Labs, and an interesting statistic for the U.S. energy use is that 20% of U.S. Energy goes to thermal uses in buildings, so heating, cooling, and domestic hot water. So as we transition from natural gas and other fossil fuels to electricity, as you say, that's going to have a big impact on the grid and peaking during the winter when we don't have nearly as much solar energy capacity.
Yeah, and I think you think of it from a summer perspective. It probably can be argued that if you make the building enclosure better, and the downside to that is that you have maybe more cooling, which are some people make that argument against passive house, for example, which in most North American climates is pretty ridiculous, especially here in the Pacific Northwest and Idaho, for example, and Montana. Look at when our solar energy resources are going to, peak in a manner where we can make that load flexible and easily fill that peak solar energy production with solar. We can cooling and that load can match up. The solar energy resource and the cooling demand can match up more closely, or with very short-term storage, where winter loads are much harder. The storage, it could be hourly, daily, and even, with some weather patterns with reduced wind output, it could be, days, if not weeks, of reduced renewable energy output. And so I think focusing on the thermal loads, especially in the winter, are something that I think we're going to have to do more and more of. And, this is a drum that Graham Irwin, for example, has been beating for a very long time. And I agree that a lot of it can be met with overbuilding our renewables, for example. Mm-hmm. That's kind of what Saul Griffith recommends in his new book. It's his new book, Electrify America, or it's just electrify. Simple. He kept it simple. Yeah. But I mean, he basically argued that we could overbuild our wind our wind resource, by 20%. And that would kind of handle the winter peaks that we would be moving to, with taking, and so he dedicates, a pretty good portion, enough attention to this real piece of the equation, that when we electrify our thermal loads, which we really, really need to, and that's for space heating and for hot water, it's going to have a big impact on the grid. He argues that it's not going to have so much of an issue with peak loads because it's a flexible load. And all, those of us in the passive house world understand that the load becomes more flexible the better the building enclosure is as well. Right. And the impact and the magnitude of those loads become less with the smaller heat pumps and the smaller equipment as well. And so, I'm optimistic that this completely be accomplished. And, he makes the point that half of electricity cost is just on the distribution side. So he makes the argument that we need to be, we're going to increase our electricity usage by, maybe 3 or 4 times as we electrify all the thermal loads in our economy, for example, in our transportation sector. But he argues that we're going to do it over similar infrastructure. Like, we don't necessarily need to build out the local infrastructure as much. That, part of that will be the distributed renewable resources, but a lot of that is the time of use aspect of it, and having a lot of flexible loads. And I think I sent you that quote from Saul in the book where he said, pretty much everything that can be a battery will need to be a battery, or anything that can store energy should store energy. And thermal energy batteries are just as important as electrical batteries. And, when you build a passive house, you're essentially building a big thermal battery that can be used to offset loads. And then that can be magnified even more with some of the storage technologies with air to water heat pumps, and having, this is something John Semmelhack, I think Little and I were messaging about just the other day, where he likes adding thermal storage, whether it's just a water tank, and there's some development now on the phase change thermal battery storage, where you can essentially have a simple little heat pump that's designed to run when there's excess renewable electricity, or electricity is very inexpensive because there's a lot of wind production or solar production. And then some of that thermal energy is stored in a cold storage tank or a hot storage tank. And then that makes the loads even more flexible. And if you have a passive house that's super low load, you're going to be able to bridge maybe multiple days with that storage tank. Whereas if you had a house that's essentially a tent, or have minimal air sealing and poor thermal enclosure, the storage will be kind of a drop in the bucket.
Right.
So you just get a lot more utilization and benefit when you have a low load building.
Yeah, definitely. At the PHI conference, one of my favorite sessions was a session by a physicist. I'm forgetting his name, but that was entitled, that was referring to the importance of passive house to deal with the dark doldrums, which is essentially this idea that in the winter, when it's dark and the wind isn't blowing, we can have a problem, right? With meeting our energy loads. And going specifically to that notion that buildings are this thermal battery, and actually doing some kind of almost back of the envelope. He has this very simple Excel spreadsheet, though, to document really what if buildings were passive house, or if we build new buildings to passive house and retrofit at a certain scale, what that means in the future in terms of an energy resource for the grid. And it's massive because of this the flexibility in loads that it represents, and the issue you're pointing to right now, which is basically you have a extremely weak thermal battery if you have a wood tent as your house, and you have a very effective thermal battery if you have a passive house. So one of the things that I really appreciated with Saul's writing is his emphasis on the yes and of all of this. That
agreed entirely.
Right? Yeah. I think that it's so common for us in the climate solution space to compete with different technologies and say, no, mine is better. You're ignoring the dark doldrums, that sort of thing. You're making good points, but the mistake is to say, this is the silver bullet. And instead, I think we can embrace this really exciting potential for electrifying everything as one of the really powerful ways to decarbonize, while also celebrating the way that passive house can support that and be complementary to it. And it's a vital piece of the puzzle that we. So I think that there might be a tendency sometimes to feel like a little bit in the old school kind of maybe 10 years ago,
Yeah, 100%.
Be like, oh, renewable energy. Wait, energy efficiency is the important thing, or electrification. No, energy efficiency is the important thing, and no, it's everything. we need it. It's absolutely yes, and there are exciting ways that there are kind of unexpected feedback loops, positive feedback loops that are virtuous cycles that happen when these different systems and changes in the grid and in our energy system happen. Ways that energy efficiency can support electrification, vice versa. The fact that there's this a more robust envelope allows you to have a smaller heat pump in the first place. Those kinds of things.
Yeah, and I'm going to finish my thought earlier where about the cost of the distribution and the benefit that we'd have of putting more electricity through the same amount of wires that we had, and what the kind of cost benefits that would have. But I do want to say, we spent all this time talking about the heat pump, which like I mentioned, is about 4 times smaller than it was. But what's more important, with the passive house building enclosure, the house predominantly isn't even heated. My house is not even predominantly heated by the heat pump, which is the funny thing, because we obsess about the heat pumps and how awesome they are, which they totally are. But it's really providing only about 1/3 of the heat in my house. And that's kind of the beauty of passive house. Like when you're kind of talking about things working with a co-benefit, is the beauty of the load reduction is that now we're actually utilizing the waste heat inside of the building to provide about 1/3 of the heat. So, in the mild weather, just my waste heat is providing from my laptop and my appliances, my plug loads, my TV, those loads in a lot of the weather conditions are providing 100% of my heat load. And then solar gains, which in my house, I have very few south-facing windows, if at all, but just the diffuse solar gain through my windows is providing about another 1/3 of the heat gain. And there's some direct gain, but it's not a lot. And so where in a normal house, 80% probably of the heat demand would be provided by the heating system, whether that's a furnace or a heat pump. In my case, only about 1/3 of the heating is actually provided by that heat pump. The heavy lifting is just being done by the better building enclosure, kind of creating a thermos that moderates the loads. And now 2/3 of my heating can be just provided by environmental, the loads inside the building, and then the occupants and the plug loads, and then the little bit of solar gain that we get. It's quite remarkable, really, that it works that way.
Yeah, it is. It sounds like you like your house too.
No, I like the house. But to know that my heat's not even running.
Yeah, no, that's awesome.
It's quite comfortable, right. And I can keep my windows open even longer. It is like one benefit of a passive house that a lot of people don't understand is it can be mild weather outside where your neighbor has a fire going. Or their furnace is blasting to try to keep their tent of a house warm. And you can have a window open in your passive house because it's being heated by just the internal gains
right.
Inside the building in the mild weather, and you can enjoy having your windows open longer, which is kind of the funny thing when people are like, "Can you open a window in a passive house?" And it's like, yeah, you can keep them open longer. And when you close it, it's actually closed is the benefit. It's not like having in a normal house where it's like your window's always open. It's just the building enclosure and you can never close it.
Yeah.
But getting back to this idea that with the flexible loads of electrifying thermal energy, for example, and, charging EVs, if it makes sense to at night, but that we can put 3 to 4 times more kilowatt hours over the same electricity infrastructure that we have in a lot of places. I mean, what that's going to do is really going to drive down that cost of distribution, which right now is, I think it's about like 6 to 7 cents a kilowatt hour is the nationwide average for just the distribution of energy. And so People like to talk a lot about the costs of electrification, but there's also going to be a lot of benefits to it, because I think we're going to be able to utilize our infrastructure kind of for a more continuous load,
right?
Rather than it being just like, dealing with a summer or a winter peak, and then the load just kind of decreases. I think the idea is going to be to utilize our infrastructure more heavily as we electrify these thermal loads and our transportation loads. It's actually going to make electricity less expensive in the long term, which is pretty exciting.
Right. And then if we can continue to drive the cost of passive house, the incremental cost of passive house down toward closer and closer towards zero, sometimes at zero for different building types compared to conventional construction, then what's the argument not to do it? It's like, it's just we're getting closer to that no-brainer moment.
Yeah, and we haven't even started to talk about all the other benefits in terms of indoor air quality and health and comfort, and so yeah, there's the list goes on and on and on. But I will say that one of the more exciting things, even than the heat pump for the passive house, is the Zender energy recovery ventilator that we're using for the fresh air exchange. And we kind of touched on kind of one of the downsides of trying to rely on night cooling, for example, which is something that when I was doing modeling for PHI projects early on, some of the early passive house projects that we worked on, we knew we were kind of maybe a little over reliant on solar gains to try to hit that heat demand target. But we were kind of tricking ourselves into thinking that, well, with night ventilation, we don't need to worry so much about it, because we can open the windows at night, cool the house down, and those solar gains that we're getting that aren't utilized for space heat, because maybe they're in the shoulder season or even in the summer months, aren't a big deal. Well, turns out there's a lot of forest fires on the West Coast.
Well, back in 2010, that was a reasonable assumption, but in 2021, these forest fires are crazy. That our air sucks.
It's not just a couple days out of the year, and sometimes it can just be relentless. And so I really, even though I have a very tight mechanical closet, that was one of my biggest design requirements, and one that I also try to echo and made heard for the projects I consult on. But is that the ability to do additional filtration on the supply air from the outside. That Zender unit is running at near 100 CFM, and so it's exchanging the 12 to 1,500 pounds of air in this house every few hours. And in the course of a day, we're talking about tons of air exchanged. And so if your outdoor air is polluted, it's going to bring all that pollution inside. And I've found that the MERV 13 filters are not enough that are built into those Zender units is not enough to provide sustained particulate reduction during heavy forest fires. And so we've equipped the unit with Zender's, has an additional filter module that lets us do a MERV 15 and a carbon filter. And I already was able to put that to use at the start of construction. Right when we first moved in, there were some forest fires, and the particulate levels in the house, you would never know that there was a fire outside.
Yeah, that's great.
And so, the internal indoor environment benefits, are just unparalleled compared to my poor neighbors that, again, they can't even open the window that is their building enclosure. And so the smoke just comes right in through their building enclosure with very minimal filtration. And then they try to filter that at that point with recirculating filtration. And so to be able to control it from the beginning, just another benefit to passive house.
Yeah, right. It's both climate mitigation and climate resilience. We can create little havens of clean air.
Indeed. So I've been enjoying that, and have a suite of energy monitoring going on. All the circuits are monitored. And we also have some enclosure monitoring as well. We are in a dry mountain climate here in Boise, so we were fortunate enough to be able to do double stud wall assemblies, which I've been comfortable with and familiar with doing in the region for well over a decade. And I know of 20 plus year old projects that have double stud walls in this climate with no issues. So monitoring those with the OmniSense moisture content sensors, and did a handful of different vapor control strategies and cavity insulation strategies in the unvented roof assembly and in the walls. And they're monitoring that just to have is for more data, and also doing indoor environmental logging in terms of temperature and particulates and CO2, and just trying to continue to learn from the project. It's easier to be more invasive in my own house than it is some of my clients. You know, they don't necessarily like me logging the temperature and CO2 levels in their primary bedroom at all hours of the day.
So, and you're gonna share your house on the Global Passive House Showcase, yeah?
Yeah, indeed.
Looking forward to that.
Indeed. Yeah. Look forward to kind of sharing some of the details of the build and methodology. And then I kind of would like to wait until I have some more monitored results and data, especially it's been a big learning experience with this Arizona damper system. That's I've used them on a few projects. Another one is one of my own commercial projects. And there's been a bit of a learning curve on that, but I'm kind of feeling much more comfortable with it. And I feel like probably there's some lessons to share on some of the quirks of that system. And they're a Spanish company, but they have great technical support. And I've exchanged a lot of emails with technical support and a couple phone calls, and they've been awesome, kind of helping me marry the system with the low load passive house, because there's kind of different needs. For example, the damper system, wanting to react specifically to comfort and trying to get the heat pump to respond right away to that comfort request, and spiking the power usage of the heat pump versus what we really want is just it to be a slow and steady just a slow and steady ramp of power delivery for the loads in a passive house building, because everything's just so smoothed out. It gets rid of those peaks and spikes for the most part, especially in the winter, a little less with solar gains in the summertime. But and so just working with those constraints, they've been awesome to kind of help me get the most out of the system.
Yeah. Skylar, this is inspiring stuff. What else do you want to share before we wrap up here?
What else do we want to share? I think we had talked about the kind of, I was modeling a proposed library in McCall, Idaho, within the last year. And kind of one of the funny things that were one of the baseline models I was doing for the project was kind of a code building enclosure was modeled. And this is a climate with 10,000 heating degree days almost in some winters. And so there's pretty much heat. When you model the project with the code enclosure, it's pretty much like showing heat in like June and July. There's still heat demand for those really cold mornings, for example.
Right.
And what I found was interesting is when I would model the lighting power reductions for really ultra efficient LED lighting suite, with the most efficient lighting operated the least amount, and then doing appliance and plug load reductions, basically just turning that knob all the way down, which is where we're at when we generally model a passive house. We've done all the efficiency things with the lighting and the appliances and the plug loads and maximize that pedal. And I just found it interesting that when you kept the building enclosure and the natural gas heating system in place, the energy use of the building actually went up, which at first didn't make sense, but obviously it does when you think about it, because the electric resistance heat that you would be getting from your waste heat from appliances and lighting is about 100%, COP of about 101, about 100% efficiency. And when those loads were reduced, the heating went to the furnace, which, takes about, 1.1 to 1.2 units of heat for every 1 unit of heat produced. And so it was actually increasing the energy use of the building. And that's what happens when you essentially have
efficient lighting and appliances.
Yeah. So that was an interesting quirk of the model that I hadn't expected, which occurs in a cold climate where, in another climate, it may have increased heating, but it could have reduced cooling load. So there was maybe an offset, or it didn't increase it, but it just kept it neutral. But then you move to an electric resistance heat, and then it's just a wash. It doesn't even really benefit you, except what little benefit you might get on the cooling side in summer. But then it's interesting what happens is, and this is kind of the one, if I can impart one thing, if you're an energy modeler out there, when you're modeling your winter heating loads, do the plug load and the lighting reductions before you start applying your thermal enclosure improvements, and you're going to see more benefit from them, because a lot of modeling is done with assuming high plug loads, high appliance loads, high lighting loads. And then when they apply insulation or air tightness, they're like, oh, it's not that big of a benefit because the building's heated for free by the internal gains. And in reality, we want to make those internal gains as low as possible and use the most efficient lighting systems and the most efficient appliances. So you should do that maybe before evaluating some of the enclosure improvements, which change the balance point temperature of the building and make it maybe so it's less heating dominated. And so, but it just gets cool then when you crush those loads down, then the payback times for the improved thermal enclosure become more evident. And then all of a sudden you improve your building enclosure and your air tightness, and you do the heat recovery ventilation system. And now the loads are 90% of what they were on the heating side. And all of a sudden the heat pump system that was completely unaffordable before or out of reach with standard building loads now becomes, much more reasonable, because the capacity is, maybe 3 or 4 times less than what it would have been with the standard enclosure. Just those little nuggets of what kind of passive house instills that unfortunately a lot of the architecture and engineering community, even to this day, they still haven't totally figured out, so that'd be the one piece of wisdom I would impart on anyone if I could.
Well, that's a very important piece of wisdom and advice. So thank you for sharing that. Skylar, this has really been fantastic. I knew it would be. And I really am so thankful that you've carved some time out to sit down and talk with me. Happy
to chat anytime, Zach.
All right,
and
man.
I look forward to seeing you again in person here soon.
Yeah, no kidding. All right. Thanks, man.
Yeah.
Well, great interview, Zach. I really enjoyed listening to you. What a wealth of knowledge. Skylar's obviously got a huge amount of experience in the industry. Almost from inception in America.
Yes, he does. And he and I do text each other often with the most recent musings from Saul Griffith or Michael Liebreich, formerly from Bloomberg New Energy Finance, and just the thinking about and being excited about the potential for deep energy efficiency in buildings to spur on the clean energy transition. So he's a friend and fellow geek, and I've learned so much from him over the years. It's been great. What were your what were your impressions?
Well, so much. We could go into a lot of details, but I think you covered off all those pretty well, and I appreciate it. There was a lot in there. So I'm just going to pull out one big theme for me was around the role of passive house in electrification and the benefits that passive house can provide, regardless of what flavor it is, because the end result is what really matters, and that is around reducing those peak demands, peak loads on the infrastructure that we rely on for providing energy. And as we transition that energy supply from natural gas and other sources more towards electricity, Skylar makes a really good point that if we just make that straight switch, we're using the existing housing stock or the design that we use at the moment, we're going to be a little bit better off, but we're going to kind of miss a big opportunity, because when we electrify, we can implement things like heat pump technology and get this massive increase in efficiency with much higher coefficients of performance. And by implementing Passive House, we can drastically reduce not just the total demand and those heating degree days I talked about at the top of the show, but it's all about reducing the peaks. And that's where the lines companies, the people who are involved in a distribution of electricity, that's what keeps them up at night, is figuring out, does my network have enough capacity to handle the coldest night in winter, or 5 o'clock in the evening when everyone comes home and fires up the heater, whatever that is. And Skylar just paints this really good picture of a house that maintains a pretty flat line interior environment, and you can just optimize it so that you're gradually bringing things on as you need them, and then off again. And really the demand is not that great. So the short story there is that Passive House can play a huge role in getting the very best result out of electrification of homes and of the network.
Very true. And I think we as a community need to do a really good job of sharing that with the world and the clean energy transition leaders and movers and shakers, so that there's a recognition of the power of the really the flexible loads, and the winter issue for the clean energy transition becomes one of loads even more than demand.
Yeah.
So the timing of when that energy is required, and Passive House just is beautiful in that it's so even keeled and constant, and so there's a lot of flexibility about when it can sip that energy that it needs to stay comfortable in the winter.
It is nice how Passive House aligns so well with the gurus of building science, and we're not competing against each other. And what we're saying around moisture control, air tightness, waterproofness, putting windows in the right place, all those things just line up really nicely. It's nice to have that reinforcement of good ideas. We're maybe on the right track.
Yeah, it's possible. It's possible.
Skylar did just remind us, though, of something really important when we're talking to people who are just coming across Passive House, that he was initially skeptical. And this is something that we hear quite regularly, but I think people tend to forget once they've been in this space for a little while, that air tightness causes a bit of concern for people. The whole concept of this European originating thing does cause people a little bit of hesitation. So I think it's just a good reminder to be aware of that just because we get it and we can see that it's obvious, it took us a while to get to that point. So we just need to be compassionate to people who are coming across Passive House for the first time.
Well said.
Awesome. We've got some stuff coming up.
We do. So we have one more week of construction tech and showcase programming before we go on a little break for our winter break here in the Northern Hemisphere, and I think your summer break, right, in New Zealand and Australia. So on Tuesday, the construction tech program will be about microgrids. So this is a good follow-up for our conversation about connecting what we do to the clean energy transition. So we'll hear from Dusan Brilik of Direct Energy Partners about microgrids. And then on, so that's Tuesday our time, Wednesday your time. Then for the Passive House Showcase on Wednesday for us and Thursday for you, we will hear from Satpal Kaur. She is going to be talking about the SSUS ship retrofit. So there is a SS United States ship that this historic huge ship that is being retrofitted, and that Satpal is working on the design of this retrofit for the envelope of this ship. And so it has all these parallels with Passive House and connections to Passive House, which is interesting because there's also that, and maybe we can find it for show notes, but there's also this historic ship that is often referred to as like the first proto Passive House, like way back in the day. Anyway, it's going to be super interesting and fun, I think, on Wednesday to hear from Satpal and about this work and how it's applicable to.
I'm guessing in a ship they keep it pretty leak proof.
Yeah, right. Moisture management is fairly important in a ship. I
think. We could probably learn a few things from shipwrights.
It's true, and man, vapor management is is an issue as well. I can attest. My dad was a live board, and I just remember all the books were completely open and moist and moldy and anyway. So it should be fun. And then we'll take 3 weeks off and be back at it the week of January 10th.
But we aren't taking time. Well, you and I are taking time off, but we will have podcasts coming out during that time. So stay tuned.
Yeah. Brand new episodes every week.
Awesome.
Yeah. Thanks.
Thanks, Zach.
Yeah.
See you again next week.
Great.